Hey everyone, welcome back to the channel. Today we're talking about something that sounds way scarier than it actually is, limits in calculus. And before you click away thinking that you're not a math person, don't worry. A limit is basically just asking, what is this function trying to do? Not what it is, not what it becomes forever, just what is it approaching? Kind of like when you're walking toward your fridge at night. You're not there yet, but your intentions are extremely clear. So, by the end of this video, you'll understand what a limit actually means, how to read limit notation, left-hand versus right-hand limits, and how to solve basic ones without crying internally. What actually is a limit? So here's the simplest definition. A limit is what a function gets closer and closer to as the input approaches a certain value. We write it like this, which reads the limit of f of x as x approaches a. But if we think about this, a way to describe it would be, as x gets really close to a, what number is f of x getting close to, or y? Not necessarily what happens exactly at a, just what it's heading towards. Here I have an example. Let's say f of x equals 2. What is the limit as x approaches 3? Well, in the table I wrote to the side, if x is 2.9, then f of x, or y, equals 5.8. If x is 2.99, then f of x is 5.98. If x is 3, then f of x is 6. So, we can see that as x approaches 3, f of x approaches 6. So this answer is 6. Now, you might be thinking, why not just plug in the number and be done with it? Sometimes you can, but sometimes you can't. For example, I have this equation, f of x equals x squared minus 9 over x minus 3. And the question I'm going to ask is, the limit of f of x as x approaches 3. So, if we try to plug in 3 here, we get 3 squared minus 9, which is 9 minus 9 over 3 minus 3, which equals 0 over 0, which is not a number. Here's a way that you do this. If you simplify it, and we can make this x minus 3, x plus 3, and x over 3, we can cancel it out, and then we plug it in. So, limits are basically a way of canceling things out to then be able to plug things in and find what is approaching. So, for this answer, we get 3 plus 3, or 6. The idea is that limits care about the trend, not the mess at the exact point. Now is where things get slightly more interesting. Sometimes we check limits for two directions. A left-hand limit means that we're looking from the left, or the smaller from the negative side of the numbers. A right-hand limit means we're approaching from the right, or the bigger numbers. As you can see, here are two examples of how we would write the left-hand limit with a minus, or the right-hand limit with a plus, because the left hand is from the negative and the right hand is from the positive. So, if we're going to look at this on a number line, the left hand is coming in from this side that I circled, and the right hand is coming in from this side that I circled. So, if we're looking in this direction, it's right hand, but if we're looking in this direction, it's left hand. So, why does this matter? Some functions behave differently depending on direction. Let's say f of x is 2 when x is less than 0, or 5 when x is greater than or equal to 0. So, if we look at the limit as f of x as x approaches 0 from the left, we see that when x is less than 0, that limit would be 2. But if we look from the right, the limit would be 5. So, because the limit from the right and the limit from the left don't match, if we have something that would be like the limit of f of x as x approaches 0, this means that we're looking at both of the limits, and the limit from the left is 2, the limit from the right is 5, so the limit does not exist. Okay, now let's talk visuals. A limit is super easy to see on a graph. When x approaches a value, follow the curve from the left, follow it from the right, and see where both sides are heading. In this graph, we can see 3 examples of different limits. So here we see that we have a hole. This circle, even though it looks big, it means that only one little spot is going to be missing from the graph. So even though from both directions it's still headed in the same place, just the section, one tiny point in there is going to be missing. And that means that this limit does exist because both sides are still headed towards the same place. Also, here we see a jump, which means that even though we have one defined point here, it goes this way and then immediately jumps up to here. So if we're looking from the left, we see that the limit is 2, but if we're looking from the right, we see that the limit is 3, which don't match, so jumps do not exist. Now, we're looking down here. This one's interesting because not only is this a hole where the limit does exist, being 1, but we also have a defined point. So f of x in this graph would be 2. So even though the limit is 1, because from both sides it approaches 1, this f of 1 is 2. Let's go over some quick rules. So first we have direct substitution. So in this example we have f of x equals 2x plus 3. Earlier we went over how if you can just substitute the limit, like the x goes to this number into the equation, then that's what you should do. So for this one, we can just see that if we plug in 2, we get 2 times 2 plus 3, which equals 4 plus 3, which equals 7. So we already solved this limit just by plugging in. Now, for my second rule, if we get 0 over 0, try factoring. We already saw this again, but for example here, x squared minus 4 over x minus 2, that goes to 0, 0. So how we can do this is we can make this into x plus 2, x minus 2, using difference of squares, and then x minus 2 on the bottom, which those two cancel out and we get x plus 2. Then if we plug in 2 into the x plus 2, we get 4. And the final thing that I want to go over that we covered in this video is know when the limit does not exist. And what I just want to go over the key basic part of this is that the limit does not exist when the left side of the limit does not equal the right side of the limit. So know that if the left side of the limit does not match the right side, then the limit does not exist. If this helped you understand limits even a little more, then congrats. You've officially survived the first hurdle of calculus. Next step is derivatives, or more of just limits, more in-depth limits. If you want, I can also make a crash course for derivatives or videos for before your exams. Drop a comment and I'll see you in the next one. Bye.